Ooh.
Yeah, that would take out a few people. All right. Okay, so recording is started. And yeah, we might want to delay a couple minutes. Apparently there was a car on fire on I-5, so. I don't know what's gonna totally.
I remember when I first came to Washington like 25 years ago. A number of times a year I would drive by cars on fire on the roads. It was just like, what's going on in Washington State?
Oh, really?
I mean, I just had never seen that as many, and then it sort of stopped. I distinctly remember my first few years was like, are they not inspecting these vehicles? Like, well, where are these cars coming from? Because yeah, like it would be like a couple times a year, like, oh, there's another car completely involved. Yeah, and I think it might have been, just might have been like,
it was just where you're driving.
Oh, who knows? Who knows what it was really? But I was just like, what's going on here?
Now, I've been in Washington for 51 years now.
And people still don't know how to merge.
Yeah, that's true. And I can think of one, two, maybe 3 or 4 car fires I've seen in that entire time.
Oh, wow.
And one of them was not local. It was up on Snoqualmie Pass.
Mm.
It wasn't a car, it was a truck. And that was pretty spectacular.
We went to the Act Theater once, and there was like a sports car that had come around the curve, and I don't know what they did, but that was not a sports car. It was a smoking Hulk fire engine. Yeah.
It's okay. C++ is here. I recognize one of those people from one of the other, that's the thing, there's so many meetups in here now. Okay. Give people 3 more minutes and then we'll start. It looks like one online for sure.
Yes.
Hello.
Hi.
I'll tell you one thing that's changed though for sure is the density of traffic.
Oh
yeah. Even the last couple of years, well, pre-COVID, I should say.
Right. Oh, it's getting very bad.
It's gotten really bad.
It's gotten better. I mean,
COVID thinned it out.
Now RTO is.
Yeah.
Think Microsoft will ever do a RTO like Amazon?
You know what? I mean, that's a good question. Since I think for the young kids who are just coming into, I mean, we have this brand new campus, right, which is incredible. And I mean, like the food and the cafeterias is so much better than anywhere else. And I do see lots of people coming in. So I think for the new, like people who have moved to Redmond and are just getting started, like the young kids, they really like to come in. And then like, in my group, there's a bunch of people I never see anymore because it's like happy hacking at home. And,
yep. That's kind of what
they've lost their offices because, so I don't know. I don't know if we'd have the space now. I mean, it always used to be about hiring people, bringing them to Redmond, to get.
Yep. Howdy.
Hello. But now we have people in our group who are remote, and they're not going to return to office because their deal is that they can be remote.
Now, one of my friends just got hired at, he's working VRSR group here, but he's in the Bay Area. Okay, looks like we're getting critical mass.
Yeah.
I'll go ahead and start. Let's see. Bring this over real quick. Okay, howdy. Welcome to the Northwest C++ Users Group February edition. First, we'd like to thank all of our sponsors, primarily Microsoft at this point, for both the reactor room and the team support, and actually our speakers from Microsoft tonight. So Microsoft Weekly, on ball. Oops. That's bizarre. Or we have stopped. You try resetting that. There we go. Try that again. Okay. And we do have a code of conduct. It's basically just Microsoft's code of conduct. It's be nice to everybody and get along. Okay. He's not here, but I would like to thank Peter for our website refresh. If you go to the website, there's been a couple of little glitches that have been there for quite a while that have been taken care of. So Peter took care of that for us. I am looking for presenters for 2025. August and on is still open. In July, we're going to be doing something a little different. We're going to do a language panel. So it won't be specifically C++. Some folks may know the Rust user group meets just across the way. We're going to partner with them, and we're just going to have a discussion of all the various new languages coming out. So in particular, we are looking for panelists to represent Carbon, which is a C++-ish language that's sponsored by Google.
Yeah.
CPP2, which has been Herb Sutter's project he's been working on. Go, C#, Mojo, Hilo, and Circle. So if anybody's interested in being a pretty lightweight panelist and happens to know one of those or is interested in learning it, you don't have to be an expert on it, just be able to kind of represent it and say kind of what it does. Get in touch with me, and let me kind of show you what that's going to look like. So we're basically each person will just do a quick little template. We've got it all pretty well laid out. We're also going to have the D programming language, and Walter Bright's going to represent that. I'll represent the C++ language. Rust will be represented by Brad Gibson, and Swift will be represented by Peter. And so basically, we're just going to have a little show and tell of, language history, just, kind of fill that in. There'll be a sample code, which actually, at least for this language we've tried so far, ChatGPT gives you a nice sample pretty directly. It's nothing complicated. It's just showing updating a variable with a couple of threads, nothing complicated, but talk about memory safety features, talk about thread safety features, talk about performance, talk about the development ecosystem, and so forth. And so if anybody's interested in doing any of that, let me know. See, you can get to me by Lloyd@cyberdata-robotics.com. It's probably the easiest way. And most of the folks here just respond to the news group or user feed or something. And you've all probably got my email address by now from sending out the announcements. Okay, with that, I'm going to turn it over to Tom, who is a principal researcher in Microsoft, right? Title? Anyway, he's going to be talking about the BBC microbit.
I'm retiring. What's in the title? Yeah. Thanks, Lloyd. I appreciate it. It's great to be here. I think I was here like 10 years ago, maybe.
Yeah.
At that time, we were coming off of a project called Touch Develop, which was an outgrowth of Microsoft's interest in smartphones, if you remember, and we had like the Windows Phone, and we had amazing little, what was it called, the Metro UI and all that.
Yep.
And and we were just bummed that you couldn't program the phone on the phone. You had to have a big old desktop with Visual Studio, and so we worked on this project where you could take your phone and use essentially a syntax directed editor and create little programs that did cool stuff. And as a result of that, we got into this whole thing with the BBC, and that was, I think, when I came and talked last, maybe. So anyway, so I'm still sort of working on that. One of the reasons I'm retiring is that I want to keep working on it, but Microsoft has other ideas for me. I mean, we're basically all in the AI tsunami, like flotsam and jetsam, and we're all like hanging on to, whatever piece of wreckage there is, and sort of overcrowding this, right? So I am retiring, but it's been a great 25 years, but I do want to continue working on this stuff. And it's fair. I mean, we all like come to points in the road where we say goodbye to old friends and hello to new ones. Okay, so anyway, that's a little bit about me. Not really. I'm going to do a quick slideshow. Let's see. Sorry. Yeah. So all the stuff that I'm talking about is open source. Everything I'm showing you here is commercially available. It's been a really interesting ride, and it's really about computer science education through sort of this retro device called the BBC Microbit, which uses microcontroller technology and a whole bunch of sensors built in. And they had a really great idea, and we helped them make that come to life in 2015 now. So what I'm going to tell you about today, though, is something else which builds on the microbit. So we have like the microbit, which you think of as maybe a motherboard with some memory and storage and compute and actually networking. It has a Bluetooth antenna, and then it can plug into, like, you can add a screen to it. And that's, I don't know, if you squint at it, does it look like a PC? Not quite.
No.
And we have like
a Steam Deck.
Yeah, right. Yeah, like a Game Boy or something, right. And then we have like USB, like we did a USB project. It's not USB, it's called JackDeck. So you can like prototype with other, I mean, the cool thing about the microbit, it has a bunch of things built in, but what if you want to add color LEDs? Well, just plug it in and it should work, right? So we've been working on this way to compose digital systems and program them. And I'll tell you about the evolution of that and how we've come to this MicroCode thing, which is to make the programming portable. Like, why shouldn't, like we did with Touch Develop, like, why shouldn't you be able to program the microbit using the microbit? Why should you have to be attached to a laptop? So right, physical computing, let's start at the ground up. What is physical computing? How do we program the microbit? And then how do we sort of make it portable? And then if we make it portable, there's all sorts of other things we could do with it. I mean, why not like use it like, Star Trek fan, like, why couldn't this be a tricorder? Like Spock beam down and like, take sensor readings and do things. And why couldn't we use these things in like creative music composition altogether? I mean, we need to have a little better speaker than this buzzer on the microbit. And why can't we like use it to like control robots and do other stuff? And it doesn't have to just be about learning computer science, but all these other things where you can use computers and sort of understand their applications. So physical computing is sort of the education term for reactive systems. I mean, we talk about embedded and reactive systems when we're hardcore. And physical computing is the same thing, sort of, but for education. So it's software and hardware that senses and responds to the real world. And in the microbit, it has an accelerometer. You can shake it, it can respond, it can make sounds, it can send messages, and it can be embedded. It has some low power states. If you want to actually write a program that just wakes up every hour and records the temperature to flash, and then goes to sleep, for another hour, you can program that pretty easily. So you can actually embed this thing, put it out in nature with some enclosure and like come back a month later and get all your readings, temperature readings or light sensor, things like that. Yeah, so the microbit premiered in 2015, 2016. It has this great display, 5x5 LEDs. It turns out with a little trick in polarity, you can turn the LEDs into light sensors. So it also senses light. It has two buttons, A and B buttons. It has it has sort of classic Arduino, GPIO, all the sort of things you would expect, to be able to do with an Arduino, but on this edge connector. And some of them, as you see, are bigger, so you can use crop clips. So this is another thing that's been really popular with teachers, is like you don't have to do lots of little wires, you have these crop clips. But as you notice, 3 volts and ground are really close to each other on the right-hand side. So there's also a learning opportunity. There's also a learning opportunity there. Yeah, okay. On the back you have an a Cortex M0 with 3 times less memory than my Apple II from 1981, but 256K of flash. You have a JST for power, battery power. You have USB with interface chip that makes the thing masquerade as a mass storage device. So you have drag and drop thanks to ARM mbed DAP-Link interface chip. You have a 3-axis accelerometer, a compass, temperature sensor is really just built into the chip. You're sensing the chip temperature, and then you have the BLE antenna. So what have people done with this through the ages? I mean, lots of this stuff is just, very much about physical activity, step counters, wearables, rock, paper, scissors on the right-hand side, a step counter on the left. Here's a cool thing we started off where you use the LEDs to actually sense light on this NeoPixel script and then actuate a servo. And then, the whole idea here is like you can make your robot, but now you can make your robot live. So you see the LEDs flash and the robots all, open their mouths. So animatronics, actually I've been talking with a fellow longtime Microsoft who used to be at Disney Imagineer, like robotics and teaching kids how to tell stories with robots. And, the microbit can be used in that sort of storytelling. It's not just about like data sensing or things like that. Yeah, there it is again. Sorry about that. Also wearables like fashion, like incorporating the microbit into things. So this stuff was all done like, 5-6 years ago. Then we had this amazing guy. He's called Captain Credible. He's Norwegian teacher and maker, and he's a musician and a DJ. And he basically used the microbit to create an orchestra where the microbits, the radio is very, very deterministic. So you can have one microbit sending out a sequence to other microbits, which are drumming, playing instruments, and he could like take a whole set of kids, like get them essentially composing with all the microbits, like streaming data over not Bluetooth, but the lower level stack. It's a sort of a broadcast protocol. And then of course robots, right? So here's like a super simple cardboard robot with 2 microbits. So one microbit sending commands to the other, and you'll see more of that here. But this was like, I think, the cheapest robot kit you could get. And so using the accelerometer to go forward and backward. Personally, I'm interested in this because I sort of see systems everywhere. I mean, obviously computing is just embedded in all these things we know, including toothbrushes now. And, and I think it's really interesting to think about when you think about like the microbit. I've been teaching in various classes where, I teach about digital systems, human design, but also biological systems. How did evolution solve problems like knowing which way is up? And fact is we have 3-axis accelerometers in each ear. We have 2, right? And so the way evolution solved that's pretty amazing, like how to create that and how does a digital accelerometer work. So there's lots of, I think there's lots of ways to approach computing, and I sort of like this idea of thinking about systems and solutions to different problems. So I was teaching about like the accelerometer, the vestibular system. Like, why do you need memory? Like, why is it good for people? And then there are interesting examples of people who've lost their short-term memory, who relive. It's really horrible life. If you can only remember 30 seconds and then you reboot. Yeah, right. And then of course, like feedback, our nervous system, temperature, homeostasis, and then, line following and all the things you often do with embedded systems. So anyway, I think there's like a lot of interesting ways to bring physical computing into education, which aren't just about, teaching CS, but also thinking about biology and thinking about evolution, how that solves certain problems. And, again, talking about these concepts of memory in humans and memory in computing systems and making analogies between them. And of course, today with AI and learning and what is creativity, there's a lot more to talk about. Anyway, so that's sort of a little bit more philosophy, which I guess we could talk about. But that's not really, that's for another day maybe. So what happened was we did this delivery of 1 million microbits into the UK in 2015 and the beginning of 2016, that school year. And then the BBC very generously gave the brand to a startup, which was people from the same core team, to take the microbit worldwide. So 10 years later, there are 10 million microbits around the world in over 60 countries. There's this website, which you can go visit, which really tells you all about the microbit, where to buy it, all the content, lots of great content, lots of tools and different programming languages. I think somebody did a Rust runtime for the microbit. I think we have some version of Pascal that runs on it. So it's, it's a very popular educational tool. It's also quite cheap. I mean, the microbit itself, I think just by itself is like $15. And so, they're pretty easy to get. The goals for the foundation, which are really coming out of the BBC experience, was that the microbit and its ecosystem should be really simple and easy to use to get started with. So that was one of their key ideas compared to Arduino. Like, let's build in a whole bunch of things, so you don't have to do fiddly wires. And some people like their fiddly wires, but a lot of teachers don't. They don't like the mess. They don't like the cleanup. So you get the microbit, it's got a whole set of things built in. And yeah, you can do the wires later, but out of the box, you can blink LEDs, you can scroll messages across the screen, you can do all of it, all sorts of things. And then really, to be very effective, you not only need the technology, but you need, content, and you need all sorts of things for teachers to manage a whole set of microbits and programming them in the classroom. So that over the years, they've been really developing, the whole ecosystem to help with teaching, and then really to make it very reliable, but also cost effective, economic. So it's easy to obtain as well. So this is a little bit more, I think, and here I've cherry picked some other quotes about inspiring every child to create their best digital future, reducing barriers of access for children living in different social and economic contexts around the world. So the good news is it's been popular, but what's the reality? The reality is most of these go to developed countries, to school systems that, have decent internet connectivity with with desktops and laptops and access to the internet. And most of the programming environments, including MakeCode that I'll show you quickly, are web-based. So you need to have a certain level of infrastructure to really take advantage of the microbit. So part of what, this whole idea of making it portable is, I want to be able to take a backpack of tech and jump on a plane and go someplace rural and do a lesson, and then leave a bunch of the tech there and with some instructional materials, things like that. So that's one idea, and so part of my idea around this whole vision of MicroCode is to really help the foundation, this nonprofit, really go further than what they've done. What they've done to date is pretty great. So what were the innovations we did in MakeCode that sort of helped to make it simpler? Well, one of the things was to deliver the whole experience as a web app, where you have a simulator, you can test your program for deploying it. Deploying to a microcontroller has not been the easiest thing to do, but it's gotten easier over the years. But still, to flash the thing and then take it out and embed it somewhere. Oh, there's a bug. So it's nicer to be able to do simulation and debugging in the web browser. And of course, the other thing for a lot of beginners, if you haven't seen, Scratch is very popular. So this drag and drop interface where you can't make any syntax errors. whatever program you compose, it does something. I can show you that something here. We can actually go live. Why not? Where is it? There it is. Yeah. So here's the simulator, and I basically go there and say, oh, on button A, I want to show a heart, and you drag that out there, and you get the heart. And then the thing that we've done in MakeCode, we're compiler people, so it's compilers all the way down. We compile into JavaScript, and over here, you can do text editing, and you can say, okay, well, on button B, I want to do something different. I don't know what, maybe a small heart. So you can transition, but you can also go back. So compilers all the way down. Yeah, and then you can go here, and I don't know how much you guys keep up with JavaScript, but it does have classes, and some of this stuff you can't edit in the blocks because it's sort of sophisticated. But what we try to do is give you that whole experience. Well, what about actually going to code? So when we go over here and we say download, we can actually download directly over web USB. We can actually create we can do many different things, but I just wanted to show you one sort of fun thing. So you can go here, and no device was paired. So I'll just download its file, and it gives me a hex file. Now that actually includes compiled C++. And where did that come from? Well, it was part of the web app. It came in the cloud. But what we did here was we essentially compiled from blocks into a subset of TypeScript. We compiled from TypeScript to continuation passing JavaScript for the simulator. And then for going to the ARM Cortex, we compiled to ARM assembly in the web browser, in the web app. And then we have an assembler that compiles it to machine code and a linker that links it against the pre-compiled C++ blob. So basically you get this web app, you get the whole tool chain, right? Once you've loaded, there's no C compiler. You can't write C++ here. But you get some of the efficiency. Our compiler is not a highly optimized compiler. But yeah, so anyway, so that's sort of what we did. And what we did was actually create a framework for different editors. So when we originally did Touch Develop and the Microbit, it was just a single experience. But we did stuff for Adafruit, we did stuff for our own boards. And so the whole idea was Blockly and JavaScript, go down to static TypeScript, which is think of it as our nominally typed version of TypeScript, sort of closer to C# or Java. And then we have these two ways to then compile it further. We have simulator, and then we do have the C++ runtime that Lancaster University did. And that's pretty much how all the boards, how the web app works for all different class of boards. And then we did a whole bunch of generalization to support different types of microcontrollers, not just the NRF class that's on the Microbit. So we work with SAMD, we work with a whole set of different microcontrollers. So the frameworks is actually quite capable in a number of ways. And then, as I said, sort of compilers all the way down. We start with Blockly. We have the web app for end-to-end experience. We have a way to annotate the C++ to say, hey, this C++ function or this method of this class, I want to expose it to TypeScript. And then we have like a foreign function interface, and we have automated compilation for a certain set of fixed types in between. So basically, we make it really easy to take your embedded C++, annotate it or wrap it and lightly annotate it, and then have it accessible, have those functions accessible from the TypeScript world, which we're running in the web browser. Unfortunately, this was done before WebASM and everything. So we also have a separate implementation of the C++ runtime to run in the simulator. So so basically we have so if we had to do it over again, we would start differently. But yeah, so we have we don't have a true emulator. We have a simulator, which pretty much for most of what people do, it's sort of good enough. But
any reason for going with TypeScript instead of .NET by?
Because we were very much like a web. We're compiler folks, but we're also we wanted to make everything very web friendly and I don't know, Silverlight, anyone? Yeah, no, I mean,
It's a teacher I have.
yeah.
I used to be in the
Yeah.
person.
Yeah. So no, I mean, we basically wanted to really be native, like web app. And so, okay, so you're asking is like, maybe for like, why didn't we have we created our own IR, right? We have our own bytecode that we then compile into
Yeah, why
and-
not go with something existing? Was my.
because it's super fast to just roll our own for
Are you
our own.
implying that .NET isn't fast? I knew it.
No, we're not talking about, so you want to integrate, so wait, so what you're asking is like, let me take this huge standard and like re-implement it. Like, what are you going to implement? Let's not go there. Okay, so we did not do that for a variety of reasons. It didn't even cross our mind. It's built for a different world and, yeah.
I'm not arguing.
No,
I don't like interpreted languages. I'm a C++.
So anyway, we wanted to be like very JavaScripty, and we needed to like support like, well, anyway, yeah, promises anyone, async and all the, it's like once you really get into the weeds about like what it takes to then make the thing reactive in the context of the web app, then you realize you better stay native, which for us was JavaScript and TypeScript. By the way, we were like the early version. We started on TypeScript when it was known as Strata. So we were like the very early adopters for Touch Develop when we moved it out of .NET land as a native app for Windows Phone. When we moved it out of Windows Phone, and we said we're going to make it a web app. We're like, and Mihao in our group was like, yeah, there's this thing called Strata on ours is working on. Well, let's do that. Okay. So we were very early on, like one of the biggest TypeScript projects that was in TypeScript itself. Anyway, at the C++ level, there's actually like coroutines and fibers and all sorts of cool stuff. I mean, it's a really small little runtime that also for instructional uses very nicely. So you could like jettison the stuff that you saw at the top and do some interesting stuff that people do with C++ as well. And then we also invented this whole new file format for flashing over USB. So there's a whole, like when you masquerade as a mass storage device and the operating system changes how it writes things, because FAT is like, it's sort of, you can do things in different orders. And then you realize like your interface solution just breaks because like the operating system changed. So we created Mihao created our own new file format that's very robust to flashing over USB. So we did a lot of stuff to make this really work well. And that's in part, it's not just the hardware that made things successful. It was this whole software stack. Then in 2020, there was a rev of the Microbit V2. We got a speaker, a buzzer, a microphone, a capacitive touch logo, but we also got Cortex M4 with an FPU and 128 kilobytes of RAM and double the flash. So that was really cool because then we could actually think about driving a display. So on the original Microbit, there's no way you could do this, right? So basically, we have we have a display
camera there.
Yeah, right.
Yeah, I don't know if it's going to see it or not.
Okay. Yeah, so basically we have, this V2 is capable enough to drive a display over SPI. And this was actually done not for something else called MakeCode Arcade, which I didn't mention, but I really should. So one of the other things that we did on the MakeCode team was basically we created all these editors for all these different experiences. And eventually, our CVP, very smart, said, Julia Lewis said, you guys are creating too many editors. There's no way you're going to be able to maintain those. And she was really right. Like, if you look at the bottom here, we have all these other editors we did. And they're great, but we really have only 3 main editors we support. One is on the right, Minecraft Education Edition, which doesn't have any real hardware, but it's embedded. It's the web app embedded inside inside Minecraft. And then in addition to the microbit, we have this cool thing called MakeCode Arcade. And this was our way to pack many different pieces of hardware into the same editor. So this is where we expanded the whole notion of what was possible with MakeCode. In particular, we defined a hardware a spec for retro arcade games, which looks like very familiar, look very much like a Game Boy, right? And then we said basically, if you build to this spec, we'll just work, and you can have a different microcontroller technology, SAMD, NRF. You can use these different screens. We do some cute configurations, so you can have different screen sizes and all these things. So here was our way to have our cake and eat it too. It's one editor, but we worked with many devices. And then eventually we also said, hey, the microbit isn't by itself an arcade compatible device because 5x5 LED screen, but with the Shield it is. And so actually James Devine on our team, he designed the first prototype of the Shield. And now there are 1, 2, 3, 4 Shields on the market, right? So these are the ones that use the microbit V2. Okay. I'm doing way too much on history here. So MicroCode. So finally, let's get to MicroCode. So so this idea that the BBC had was for children, different, reducing barriers of access. So the idea with MicroCode and with the Shield, display Shield, is to bring the microbit to people who might not have ready access to laptop, desktop, reliable internet, mains power, as they say in the UK. And as well to bring it to earlier ages. So, Blockly is cool, the JavaScript is cool, but you could simplify the programming experience even more. And then the other idea was to, try to go with a completely visual interface that, doesn't assume literacy, right? So Blockly still is fairly, even though it's colorful, you need to read it. And then the whole idea was arithmetic. Should we go to a simplified numeric system? And if you think about when you're learning to count, you learn on your fingers, and before you get to base 10, you're doing simpler stuff, right? So anyway, these were a couple of different ideas, going portable, but then also thinking about simplifying the interface. In some sense, we had to simplify the interface because we can't drag and drop blocks on a 320 by whatever that screen is, 320 by 160. So we had to make some assumptions. So what we did was we used MakeCode Arcade, and we programmed essentially not a game for the microbit. Because the main use of these originally was, you program your game in MakeCode Arcade, and then you play your game here. But now the idea is different. So this is the part where everybody gets to play along. So again,
I think these are the
of course you return them, or you're going to give me $80. This is not cheap.
It will be all checked at the door.
No, if you want to buy it, I'm happy to sell it to you, but at a little markup, I'll take $100.
Tom, you put air tags in all those, right?
Yeah, right. Okay. So how many did I hand out? 1, 2, 3. Okay. So anyway, this is, by the way, everything we've done is open source as well. I think I said it before. Okay, so let's take a look. This has got what Scratch calls horizontal mode. It's got a very visual interface. And what I'm going to do is why don't you just start with me, and we're going to go through a little, just demo together. So I'm going to bring it up in the web app because, we do everything in the web as well as on the hardware. So what I want you to do is go to the samples, and you will see, what's going on here? Oh, that's interesting. You will actually only see these two tiles. Mm-hmm. I want you to click on the plus. Okay, so navigation, sorry, for those of you who are not gamers. The D-pad is used to navigate the cursor. The A button is used to select whatever you're on, and B is always to go back, essentially.
I see just a plus.
Okay, so you have on your Shield, you have a D-pad on the left. That lets you navigate.
Or rather a D-stick.
Oh, thank you.
Very important.
That's true. It's not a pad, it's a stick. So okay, can everybody navigate left and right first? Everybody can do that? Okay, so then when you get to samples, click the A button, and the A button is funny. It's the one on the inside, right? Which one is it? That's on, actually, I can never remember. Yeah, it's yeah, exactly. A is on the outside. Click the A button, and then you should get to a screen, and the screen won't look like mine. It will have these two tiles. Okay. And I want to start at the empty program. And so let me know when you've got to this screen. Do you have this? Yeah, okay. If you went to the demo program, just go back. Yeah. Just use the B button to go back. Yeah. And then just start. Yeah, okay, super. Okay. So now we're going to do the Hello World program. And the way you do the Hello World program is very simple. You just select, you just hit the A button. And it will bring up a menu, and this is a menu of events. And don't move the cursor, just hit the A button again. And now you will have programmed your first tile, right? Which basically says, okay, I'm looking for a button down event, okay? And you see the cursor move to the right. So this is okay, so just keep clicking the A button. Okay, so now you are specifying which of the various things that can act as buttons on the microbit can select. You click the A button again. So now we can move back, and we can see with the tooltips that we've created an if. If this rule says if you press the A button, then we're going to do something. And again, click the A button again, and click it a second time, and you're going to have this show image. And now things get a little more interesting. When you click the A button, you're going to have two tiles, but you click the A button again. Now you're in an editor that lets you move around in 4 directions, and use the A button to toggle. You use the A button to toggle. You use the A button to toggle the LED that you're currently on. So now you can add a nose to this. I don't know. You can turn it from a happy face to a different face, whatever you like to do. And when you're done with that, hit the B button to go back. And what you should see is, now you have a rule. You have your first guarded command, essentially. When you press the A button, show this thing. And now this is an unfortunate part of the fact that we have an A button on the microbit and a B button on the microbit and also on the shield. So we've been talking about using A and B buttons on the shield, but now if you press the A button on your microbit, which is the one on the left, you should get whatever you programmed, right?
Oh.
Okay. And what kids love to do is animations and storytelling. So you can go and create, I had one kid who was like, why does it say error message 020? I'm like, oh, you're out of memory. Your program, you exhausted the memory of the device. So now so you see what he did was he just kept going, and this editor, if you keep going, will, eventually we're going to have to scroll.
He went through 100K of memory plus on that.
Oh no, you got to remember we're using RAM for all sorts of stuff, right? And
I know.
It's not like we've optimized this. So yeah, what he basically ran out of space. So keep in mind 128K, we need 10K. We need 10K just for the screen, right? And if you want to do double buffering, you need another 10K. So 20K is gone already.
Okay.
To do double buffering. Right, where we have a 4-bit color, we have a 16 color palette, so 4 bits for that, and you can do the math. So yeah, we're packing a lot into a little here.
10K for this buffer or this LED buffer?
No, there's a screen on the bottom. Yeah, of course. Okay. Yeah, it's 320. It's 320 by, well, it's actually 160 by 120 with 4 bits. So you can do the math. It's about 9,000 something.
Yeah. I was going from the other side because your little image is like an 8x8-ish or something. So you're like, 64 bits or something.
No. This thing is.
That's tiny.
This is tiny. Yeah. But, over time, it ends up you don't have a lot. You can't do really large programs. So we can, if you want to go back, you can go back and you can select this other program. And this other program will show you a little bit more. It'll show you that you can do things in parallel. Like you can do 2 different things on the A button. You can make a happy face and a happy sound, or you can make a sad face and a sad sound. And so there's a lot of things that you can do with this simple programming model. Essentially, think of it there being just a loop around this whole program. And it's just saying, wait for some event and then do what's on the right-hand side. And if you can combine the actions, somehow do that. So we're actually using the fibers in the C++ runtime to do the sounds at the same time you're doing things with the LED. Okay, so back to the slides for a second. So yes, so you successfully created your first little programs. Oh yes, and now you're going to make lots of sounds and drive it. The other thing to notice, I don't know if you notice when you edit a program, how there's a little circle on the microbit screen. That's update. So as soon as you make an edit, boom, your program's live. And the other thing you can do, which unfortunately, well, actually, I can demo. The other thing you can do, which is pretty cool, is if you have a battery. So who has a cool program they want to show? Okay, do you have a program? What does your program do?
No, I'm not saying.
Okay.
I just talk about.
Oh, okay, so just let here. Hey, good catch. Okay, no problem, no problem. Okay, so here it is, and boom, there's this program, right? So basically, even though we're not connected, we can still run the program. So you can actually have the experience of programming it, taking the microbit out, and the program's still resident. It's in the flash. It gets loaded by the runtime, and you continue on. Okay, so that's that's the basic idea of microcode. And now we're back to right. So fun and creative, make it simple. Icons first, text second, very simple navigation, hopefully accessible. I mean, obviously you still need to be able to see pretty well, especially with this tiny screen. And then this cursor-based editing, which you just saw. We did the cursor practice. We went through the demo. We spaced out, which is the way you create your first rule. Creating a second rule. Yeah, so essentially the programming model is really simple. It's if you've seen if this then that or guarded commands if you're into Dijkstra. When there's a microbit event, so we have that modal dialog that gives us many different events. So you can react to the buttons, you can react to the movement accelerometer. And what I did was I took basically all the beginning microbit programs that are done with MakeCode, and all of them can be done with MicroCode. So one nice proof of concept is that these beginning programs are generally quite small, but you don't need Blockly to do them. You can use a very simplified. You don't need full syntax of if-then conditionals and everything. So it's a slightly different computational model, but you can do a lot with it. The other thing is you can also do radio, and I'll show that in a second. Right. So when there's a microbit event, and then each of these right, as much as possible, we try to have the visual logos correspond to something on the board. I'm not always successful with that. I mean, how do you show the radio? Maybe you should really show the shape of the antenna on the icon, but we didn't have enough pixels for that.
Do you have any concept like a channel where different program threads can talk to each other?
Yeah, I'll show you that. Mm-hmm. Yeah,
it reminds me of kind of communicating sequential processes. Kind of, if you had that.
Well, what I'll show you is we can have two different microbits communicating with each other over radio.
About
within the same.
Yeah, two events triggered by different thingies talking to each other.
Yeah, we don't have explicit support for coroutines in microcode. We have that in the underlying runtime. It would be interesting how you would expose that.
Some kind of call it a channel or what, like Occam used to.
Yeah,
I don't know if you've heard of Occam.
Yeah, I know Occam. Yeah, so I'll show you the extent to which we have channels, but I don't think it's rises to the level of. So let me show you quickly what we do have. So you do want to have state, and you want to pass state forward sometimes, right? So let's see, where am I here? So one of the things, let me see, do I have a demo preview? The nice thing about the web is I have a lot more memory on my laptop. So let's see, I have this sample. Okay, so here's like, this is not exactly what you want, but it's getting sort of close.
I'm not sure the screen update.
Yeah, the screen's on.
That's the same thing I ran into. Just unplug and replug the HDMI.
Okay.
Reboot your computer, install all the drivers.
No, thank you.
That's what we already solved this problem once.
Okay, so let's see. So we should be looking at a program very quickly, which is, oh no, you're kidding me. Okay, you know what? Let me take PowerPoint out of display mode because I think it's somehow taking precedent. Yeah, in the driver's seat. Okay, so this is rock, paper, scissors. The idea of rock, paper, scissors is you're gonna figure out on your own what you want to do, rock, paper, scissors, and you're going to shake the microbit and it's going to come up with its own choice. So how do we do that? So we actually have a single page, well, a single set of rules. We basically say, okay, when you shake the microbit, you're gonna set variable X to the roll of a 3-sided dice. Oh, did I mention to you about counting? This is our numeric system. It's base. Well, okay.
That's cute. I like it.
Yeah,
That's cool.
Yeah, it doesn't have 0. We can't subtract. So if you want to do a 5-sided dice, you could do it that way. Or if you want to do 8-sided dice, you do that. So you get larger numbers. Okay, so that's a 3-sided dice. So okay.
One of those rules could trigger another.
Yeah, you're getting ahead. Okay, I'm gonna tell you. Right. So now it gets to the channel idea, right? So what is this thing? I sort of think that this is a channel. What I'm going to do is put a value into the channel, and when I put a value into the channel, even if it's the same value that was already there, it's going to trigger these guys.
Change event.
Yeah, right. So it's a change event. It's a change event on a write, and it doesn't matter what the value of the write is. So now, once you've written 1, 2, or 3, then these 3 become active, and they're mutually exclusive, and that does the trick.
Good enough.
Okay. So we have channels. Now the semantics.
You're calling it something else.
Now the semantics is you can easily write an infinite loop with this, right? You can increment. You can also so you can increment. Oh yeah, all sorts of good stuff. So as soon as you have two variables that you can reset and count, you have Turing complete. You only need 2 counters to simulate the Turing machine. You would need a lot of, you'd run out of memory before you could simulate anything interesting. But yeah, okay. So where were we? This was okay. So that was, yeah. So I was going through sort of the programming constructs, right? And so yeah. So we have so we have all of this, and I realized we did start at, when did we start? Did we start?
6:30-ish.
And I sort of said 40 some odd minutes plus demos. So let's finish up.
Yeah, we got another half hour.
Okay, let's finish up with some demos that show off some more of the tech, and you feel free to play. You can play more. So okay, so the other thing we want to do, is we want to be able to allow the kids to prototype with other things besides the what's built into the microbit. So we also created this plug and play system, and if you pass this in, you can just try it. And so we basically have a true bus here with little modules. This is RGB LED module. We have a RGB LED module. We have a button module. And once these things are plugged in, unfortunately, I can't show this to you on the screen. Once these things are plugged in, then we can do things like respond to, like when we click the button here, we turn on the lights, right? And then when I click the button here, I turn them off. Click, turn them on, turn them off. So we can create a digital system that has peripherals, and then as before, you can unplug all this stuff and plug it back together. And what I haven't got here, what I haven't shown you here is magnetic rotary project. Right. So then what we have, just to show you again, so we have the microbit. Now it's decoupled from the screen, but it's got that program on it. we've got this, what we call a jack adapter. So we have this jack DAC down here, and we have some power over here. All right, so again, you should be able to program it, and then, yeah, there we go. Yay. So the program is running, right? So I programmed it here. What you didn't see was that when I add these into the system, the programming interface recognizes I have new devices, and it adds them to the events and the actions. So one of the ideas is, you not only want to build stuff that uses the microbit, but you might want to do other things. So we have buttons, LEDs, light sensors, sliders, all sorts of stuff. And we have manufacturers for these jack DAC kits as well. The other thing, I've been working with some partners with is to think about this backpack. So what would you need? And this is like a lot of tech without the content, but what would you need to sort of jump in an airplane and go somewhere and like run workshops and then leave some stuff, right? Where like it's all pre-programmed, you don't need internet. And so the other thing I've been experimenting with and trialing is also having, introducing the programming. Maybe you won't have enough microbits or shields for everybody, so you're going to have to share. But you could have like stacks of these laminated cards where you talk about programming the system. And, again, we have pictures to show how the events in the user interface correspond to things on the microbit. And again, cards are designed so that, you don't need to necessarily, read in a particular language. And so we could also imagine a booklet or something that is localized that describes what the cards are. But the cards could be produced hopefully in a way that they don't need to be localized. And then and then you can have games about creating programs. Somebody can lay out the program on the ground, and somebody else can code it. Right, and you can sort of participate that way. So we've done quite a bit of studies with MicroCode. We haven't gone into the rural. That's the next goal. We've done it with classrooms where we compare MicroCode to the microbit solution with MakeCode, and we see a lot of great activities that the kids are doing with MicroCode where they can roam around, especially temperature sensing. Like some kid could take, they can write a program to sense the temperature and print it out on the display, and then they can run around to different parts of the classroom and try it out. Right. And that becomes very quick. Like you don't have to go back to the computer, plug it in, program it. You're basically taking the whole idea of a rapid prototyping of like creating your program and running it and seeing what happens. And you're taking, but you're not requiring the laptop or the PC and the the USB connection and all of that. So we've been working with a Canadian nonprofit called Steam Labs to get experts to brainstorm, and we're running some workshops in Canada. And then the other thing I mentioned is the second bullet is really to also show that MicroCode can cover a lot of the beginning projects. So we talked about, I mentioned everything's commercially available. Before I get to that, let me just show you. So the other thing, robots are super popular, and there's a bunch of robots that have been created for the microbit. So, the microbit, there's a chassis. These are very basic robots. And generally what people have done is they program their robot controller in MakeCode and then like put it in here, and then it works or it doesn't work. And then they have to go back. So with MicroCode, the idea as well, let me show you again. If we go here, you might notice we have it's not updating again. Thank you very much. Yeah, and this time we know why. Okay. So the other thing we have in MicroCode, are we back? Yeah,
Yep.
We're back. And I don't think I have this here. Is we have a wall sensor and a line sensor. Where did those come from? And we also have actions like send a radio message to the robot car to go forward. All right. So what I'm going to do here is like a simple program. Like the simplest thing we teach the kids is like, okay, when you press the A button, tell your robot to go forward. So let me show you that. That's always good fun. Do I have a MicroCode? Yep. Okay, so here's, now that we've done this with 20 kids in a classroom. So each robot has a number on it. That's the radio channel it's going to listen to. So this again comes where the math comes in. So the first thing I have to do is I have to tell the microbit what channel it's going to compute on, send on. And so I'm going to set the radio group here to 11, which is 5 plus 5 plus 1. Okay. So now I can do a quick test. I can just also tell that robot car, which is not on. Just as a quick test, I can also say, when I press the A button, I'm just gonna tell it to light up green. Okay, because it has these LEDs. Okay. Good. Okay. So now I've got a green is for go. So the other thing I better tell it to do is move forward. Okay, and so now we do that. Yeah, and the kids are like, "But the robot isn't stopping." It's because it's a stateless protocol. So let me quickly tell it to stop. And the A button is released. Yeah, we're gonna burn that thing out. It's okay. We're gonna tell it to stop. We stopped. Okay, so did we stop? Okay, and we're also gonna tell it to go red for stop. Okay, so now I press the A button. Yeah, and I release it. So now basically I have a car that goes forward, and then stops, right? And again, I could use the accelerometer, but and we have kids just running all over the rooms. It's sort of crazy pandemonium. And then kids are like, "Oh, I can control somebody else's car." Why is my car going backwards? So yeah, there's a lot of opportunity there. So the robots are amazing. And the other thing, because the Lego patent has expired, is these things come with Lego compatible things. So the kids, especially the boys, I think they like the battle bots. So they create crazy Legos. And the why is my car not moving? Well, you just added a pound of Lego. But yeah, anyway, so that's so the robots, Jack, the whole idea is sort of this modular system where you sort of, pay as you go. Like you can start with just the microbit and go from there. So I think that's, let me see. That's this other, I had two presentations, didn't I? I don't even know which one I'm looking at now. That's the good one.
So I'm curious.
Yeah, please.
It seems like the microbit can do a lot already, but you said that you're retiring because you want to work on it more. What do you see yourself working on?
Yeah, well, I mean, basically, oh yeah, okay. So yeah, what am I going to work on? Well, this ecosystem needs some. There are many holes in the ecosystem, right? Where so one which I'm going to keep working on is trialing this thing and really trying to see if it fills a niche, like this idea of going into rural places where there is an internet. So that could take me probably my full time if I devoted full time to that. So I'm partnering with a bunch of people to really see does this tech and solution really address a problem? And obviously there are other things like how are you going to charge the stuff and looking into that. So MicroCode is a prototype right now. So one idea is how would we actually take it to production and really either make a product out of it or work with nonprofits and really evaluate this idea that it could help, because right now it's cool demoware. It's not demoware. In some sense, it's a prototype, right?
Yeah.
But how would you? Yeah. So that's one thing which is very much top of mind. So the other thing is the other thing to think about is, well, what else can you do with this sort of this sort of combination of tech? So it's portable, but there's other things that you might want to do. So going back to the idea of the tricorder, I worked with a student at Lancaster University, and he created what's called microdata. And so the microbit has all these sensors, right? But the 5x5 matrix is not really good for showing you data over time, right? but this guy is. So with the microbit right now is if you want to look at graphs of the data coming off the accelerometer, you need to like either have a Bluetooth connection to some app or like over USB and MakeCode, it'll graph it for you. So again, you need some more capable hardware to have the display, but now you can do it here. So the idea, the sort of the second big idea perhaps, is that there are many apps that you might write, not just MicroCode, that would be appealing to teachers perhaps for other subjects. So this idea of physical computing is maybe interesting for more than just teaching computing concepts. Like maybe like with JACDAC, you could actually use this in your chemistry lab to like, put a probe in solution and see how it heats up and, see that data live. Right. So microdata is a prototype that we've created, a student at Lancaster. And so we're going to be trialing that with teachers who are, doing like data gathering, right? In the wild or, and so with microdata, you can actually plug in, learn about all the sensors, do live graphing, and then you can set up a recording session and then like take the microbit out, encase it somewhere. And remember how I said before, you can come on, you can basically set up your recording every hour, wake up, record the temperature. And then, you can come back later and then plug the microbit back into the display. And then we have another student we're thinking about like micro music, right? So that's the other sort of strand is like, can we develop a community to build these apps and really also partner with teachers to sort of leverage the microbit, because a lot of schools have bought into the microbit, but they're not like realizing the full potential. So this is sort of the other idea is like, can we leverage the technology in other classes and subjects? Yeah. So those are the two big things. I think that'll keep me busy for a while. And then there's, always bugs in the system and all of that. But yeah.
Are you in any way involved with I missed your introductory slides. Are you involved in developing of the hardware?
Oh, thank goodness, no. I'm Steve Hodges at Microsoft Research Cambridge was very involved in that. And also like the hardware here, the JACDAC. Michal Moskal on my team, actually, who's an amazing developer, really became familiar with Eagle and he started prototyping. So we had we also have local hardware expertise. Gavin Janke helped out. We had a bunch of other people doing the hardware. You get me with a soldering gun, I'm very dangerous. Things are not going to go well. So yeah, fortunately, and now with our partners, we have quite a few partners who are producing hardware. Yeah.
It reminds me historically, way back in late 80s, early 90s, there was a BBC Micro.
Yes, of course.
Yeah.
Right, that was the Apple II. That was a 65-2 based computer. That was essentially the Apple II of the UK.
Yes,
Yeah.
and it was supposed to have been very successful.
It was.
BBC thingy, branded thingies.
It was BBC, and they did TV educational programs saying, "What's a personal computer, and why should you care?" And so like Evan Janke and Steve Hodges, the guys I know on the team from the UK. This is what they cut their teeth on. They're essentially the same cohort. While I was doing Apple II, they were doing BBC Micro.
MSR Cambridge, Microsoft Research.
Steve was at Microsoft Research in Cambridge. He's a professor at Lancaster University now. Yeah.
Oh, okay.
Yeah.
Good to know the history.
There's a long, I didn't even go into that, right? There's this whole long history, like why did the BBC even do the microbit? They had this whole history of in the 80s doing the micro. And the microbit was like, they're like, it's an IoT device. It does Bluetooth, okay. But, the whole idea was like, now that, because of Moore's Law, you can like have this device that you can embed now. And so, yeah.
They have this computer history museum in Mountain View.
Yeah.
You should know.
Oh, yeah, of course. Yeah. It's amazing, right? And we have one here.
I remember they had that huge.
Yeah, not anymore.
I'm so
sad. So sad.
I was able to go there.
I can't imagine Paul Allen funded, right?
Yeah.
Yeah.
And I don't know why somebody didn't step up to
There's a computer history museum that used to be open down in Seattle. Right before COVID, they had actually opened like a VR and modern tech exhibit. And then down below, they had the punch cards, and they had a huge server room.
EMP?
Hmm?
Was it anyone near the EMP
No.
experience music?
No.
Too expensive. Better.
Yeah,
But it
no.
was funded by Paul.
Yeah, I believe so.
Yeah, it's not really unfortunate.
I still have the little card that I made from one of the machines there, and I was able to play against the chess computer.
Computer history museum, you have a huge steel disk,
Mhm,
hard disk.
mhm.
It's massive. I mean, that's the move for spinning it up. And many tracks of head crashes and
Yeah. Well, thank you so much for the time. I appreciate it a lot. If you'd like to play a little bit more, I'm happy to stick around.
What is the
Yeah.
difference between this game bit thing and the colorful one that you got?
This one?
there? Yeah.
Well, okay, so this one has the small screen.
Mm.
That one is double the screen size, but we're still using the same buffer. So each pixel here goes to 4 pixels there. Because that has double the resolution, but we're not making use of it.
Oh, okay.
Yeah, we're actually adding support for that. Yeah, so the basic difference is bigger screen. This is all buttons. And that has a much bigger LiPo than this one. They both have LiPos inside. So this one is substantially cheaper because I don't know what their production process is for that, but that one is like $60 and this one is molded, I think. And of course it's smaller, the cheaper components. So, I mean, the components are less.
I mean, this looks very, very 3D printed.
It does, doesn't it?
So I don't know why that would be 80
Yeah,
bucks.
that's-
So
Sorry? You don't know it will be.
I don't know why it would be that expensive. Maybe like the internal components or something.
Yeah, I don't know. I mean, it's from Taiwan. That's what they charge. It's like, I really like it. I mean, it's pretty solid as you see. It gets dropped. They get dropped, and they've been super destructive.
Have you ever thought
Yeah.
of, since it does get dropped a lot, have you ever thought of making one where you slide the microbit in and then there's like a casing that you put
That's a
on?
really great idea. In fact, like if you want to go out in the rain, do stuff.
Mhm.
Yeah. No, we have had prototypes where we have like a microbit slides in the back and then it's like super square, like, so like the front of the microbit, I don't know, it's sort of,
Or something like the switch, switch mechanism where the switch has like this little pull-out tab and then you put the SD card in and then you put the tab back in.
see, yeah, right. So, yeah, again, that's really interesting, right? I think there's a lot of room for innovation in the enclosures and everything. I mean, we don't specify that.
Mhm.
Basically, like if you see a bunch of the arcade things, they're just PCBs, right? I mean, Adafruit, with the reason like KittenBot, they started with a bare PCB,
Mhm.
but what we realized with working with the kids was that they'd pop the buttons. They abuse the thing, and then we had the experience with this where, I mean, it's just fairly indestructible. I mean, somebody who really wants to go after it. But then we talked to them, hey, if you do an enclosure, and so they've completely abandoned the SKU that is just the bare PCB. So now this is all they sell, and it's great because this thing again it's just for little hands and dropsies and all that stuff. And that's what's great about the microbit. I mean, these things, they get submerged, you dry it off, it works. I mean, these things are just like, except for that 3-volt ground thing, they're pretty indestructible. The most sensitive element is probably the USB thing, and the JST also. The problem is the JST connectors are so fragile. That's why for like with JackDack, we spent a lot of time on like making this connector that's double-sided and part of the PCB. So like the kids come and they rip it. It doesn't really, so part of the learning from the microbit was like, you got to make this stuff durable. And so once you get, into this space, then the enclosure is really important. So to your point, yeah, we'd love people to innovate in that space. And I think there's a lot.
I personally work with kids, and honestly, if you can make a product that can get snot and spit and get thrown in water because they're like, ooh, it flows.
Yeah.
Product.
That would be sort of amazing. So one of the things we did with the kids in my church class was teaching them about computing and the relationship to like biological systems, because the religious education person was like, you're going to teach computers to the kids in church class? How are you going to relate that to like being a human? I'm like, no problem. So the thing we did was like, I filled up a sink with hot water. And then I'm like, I wanted the kids to do temperature sensing all around the room. So yeah, I just got a plastic box and we put the microbits in there, and just closed it up and heated up. And I was like, hey, be careful when you do that. Don't drop it. Let's put it in the box first, outside, then put it in the water. But yeah, it'd be super cool.
And what do you see the target audience for this? Is this the kids and the parents or the school districts? What is
the microbit was originally with the BBC, the goal was middle school. So with MicroCode, we've done down to like, I would say third grade pretty successfully. And then with the microdata stuff that I showed, to do data science, you have to know plotting and some geometry. And, so that would be like middle school up into high school.
But my question is more, are you going to schools to sell this? Or are you going to Amazon to sell this to kids?
Yes, individually. So the Microbit Education Foundation, they go to countries and to governments and school systems, and they sell there. And they try to make like big deals because they make money on each microbit sold. Right. They don't sell the microbits, but they can make deals, and then for every microbit that gets sold, whether it's on Amazon or there's just many resellers, right? But the Microbit Education Foundation is owning the brand, and they're owning the whole content and the website, and we provide the programming environment, but they're the ones who are going out and making that. Then people always ask, well, can I buy it for my kid? Yes, you can. So you can go to Amazon and get singles, or you can go to Adafruit or SparkFun. But yeah, you can find like pretty much all of this stuff, commercially available for one-offs. Yeah.
I have a question about your choice of TypeScript again.
It was my choice, by the way. So, he's the guy. He's the guy who did it.
Keep hopping on this, but this requires a minute of back.
Okay, sure.
My name is Patrick. I was recruited for the Phoenix team in 2006.
I know Phoenix.
And then,
Eric Roder, Makeup Shooter Stava got together. Yeah, I know the history.
No.
And it was going to do
it was Chris McKenzie, etc. They were split up into part of which it went into MSR, your team. Part of was Singularity.
Singularity.
That was my question. So you don't seem to have that much of a good opinion about .NET.
No. It's not about an opinion of .NET. It's like we never even thought of it. Actually, I don't think it even crossed their minds. That's a thing for the enterprise. It's not. I mean, you have to understand our context, where we came from. Like we did .NET when it was appropriate, which was Windows Phone and a native app. Yeah. And then once we went to a web app, why would we even think? Why would even it cross our mind? I don't think we had any discussion about should we be like should we take our code base and retarget it for the web? No, it was like we're gonna like.
No, my question is the other way. Like you guys were building an operating system called Singularity, which was supposed.
No, you're talking about somebody else now.
Oh,
I don't
know. Not me.
So you're talking about MSR.
Okay, that was my opinion too. Who would build an operating system, especially one as lean and mean as Windows? Okay, not me. Not me. Okay.
I mean, we can talk names, but I'd rather not since we're recording. I mean, it's sort of fascinating, right? The history of C# and Sing Sharp, and then there was Midori and all these things. There like, what does it take to create a new language in a company? And I think, and then, why didn't we do Rust, or why did it come out of Mozilla? Why didn't it come out of what we did? There's so many forces at play in the language space, but yeah, it's a fascinating subject, but. Yeah.
I never did find out what happened to it, only nowadays.
To what?
Was it?
You found out what happened to what?
To
Subject?
Midori Singularity, that had part of that entire project, because I never get to talk to those guys. And afterwards, even what stuff came back to, he did, okay, just
Okay, we can talk, but please not on.
Yeah.
We can
On that
take
note-
that offline.
Yeah, on that note, folks, we do have about 10 minutes left before we lose the room.
Okay.
So we should get all of Tom's toys back.
Unless we want to buy something. No, actually, I want to keep these because this is my.
I did not bring my card reader.
Thank you.
It might be an awful coincidence, but just today, my BBC microbit arrived, and I also bought an Arduino Nano 33BLE2. I'm going to compare them.
Oh, wow.
I have a very specific application.
All right, you too.
Oh, wow. Okay.
Experiment, but this thing looks like a.
This is a nice.
The only thing apparently says programming conference.
So you don't mean no confidential.
Yes.
No, I appreciate it. Yeah. No, the whole language space, I mean, it's fascinating.
Yep. With that, folks, I'm going to wrap up the meeting real quick, and we will stop the recording a bit. Folks online, thank you very much for attending, and we'll catch you guys next month.
Thank you so much.
So what is the Jack Dack? The bus is in